Hello, good morning, afternoon, evening, night, from wherever you are watching. Today, our concept is going to be about rational numbers. This lecture is for class 8 ICSE. This is the first lecture of our term. So, today we are going to start off with rational numbers. Okay. So, before starting off with the chapter, I want you to know what are natural numbers and how they are represented. Rational numbers are nothing but numbers that are represented in P by Q format. P by Q. Now, what are P by Q here? P and Q are integers. So, as they are integers, it can be positive as well as negative. So, integers can be positive or negative. But there is only one thing that we have always have to keep in mind. This Q cannot be equal to 0. Okay, because if the Q present in this type of numbers is 0, then the number will become undefined. Whatever be the value of P in integer, the Q, if it's 0, it will be undefined. So this will be undefined. Thus thus the main theory of what rational numbers are is rational numbers are numbers in the form of P by Q, where P and Q are integers and Q is not equal to 0. Okay, now let's begin with the chapter. Okay, now first, I've already explained it to you, but let us watch that through a video. So the video is about what are rational numbers.
All of us know what a number line is, and the numbers we see here on the number line are called integers. On the right side of 0, we have positive integers, and on its left, we have negative integers. Integers we are familiar with, but what about numbers like these? 1 by 3, 5 by 6, or minus 7 by 12? Each of these are numbers, but we don't use them as often as we use counting numbers. Such numbers are called rational numbers, but we need to define them well. We cannot say numbers like these are rational numbers. We say that they are of the form P by Q, one number in the numerator and one in the denominator. But there are a few conditions we need to know. P and Q should be integers. We can have only integers in place of P and Q. And there is another important condition. Q should not be equal to 0. Why do we have the second condition? Say I ask you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what will give you 3? There is no such number. This value is undefined. So this is the basic definition of rational numbers. It is a number of the form P by Q, where P and Q are integers and Q is not equal to 0. There are many questions that should pop up in your head when you see this definition. What is the difference between rational numbers and fractions? Are integers classified as rational numbers? What about 0? How do we plot such numbers on a number line? And how do we compare two rational numbers? For example, if you're asked to compare 1 and 5, you could easily say that 5 is greater of the 2. But what if you're asked to compare numbers like 6 by 7 and 13 by 15? How would you find out which one is greater? Don't worry about it. All these questions will be answered in our videos on rational numbers.
Okay, so this was about what is rational numbers. So let's continue with the next portion. So Where do we find rational numbers? Okay, rational numbers are everywhere whenever we are talking about any particular mechanism, but in fractions. Fractions are also part of rational numbers. So we say, I need half tablespoon of salt. I need half tablespoon of salt. I need 3 by 4 cup of sugar. Okay, it's like that. Okay, so wherever, like for example, I do not need a foot. Okay, I need one half of a foot, three-fourth of a foot, anything. 7 by 8. I need 3 by 4 slice of a pizza. Okay, everywhere this 3 by 4 numerator denominator p by q format comes. That is nothing but rational numbers. Okay. Now again, see, this is a wooden piece slab. Okay, so this particular slab will be nothing but here 3 by 4 is present. So this entire meters, and always remember meters are something that are always going to be present over here. Okay, so this entire thing is of 1 meter. For example, 3 by 4 means it is 3 part out of the 4 part of that particular thing. Okay, so this is what is, where do we find rational numbers? Now let us come with the first question. Let's read what the question is all about. Okay. In a school garden, length of a flower bed is 3 by 4 meters and the width is 2 by 3 meters. What is the area of the flower bed in square meters? We all know what is area. Area of, first we'll find the figure out the shape. Okay. Length of flower, area of the flower bed is square meter. Okay. So length of the flower bed is like this, right? So how we realize that the area we have to found is of a rectangle and not a square, as both of the length and breadth are different. We have already found that it's a rectangle. So length here is 3 by 4 meters. Breadth here is going to be 2 by 3 meters. And we know area of a rectangle is nothing but length into breadth. Length here is 3 by 4. Breadth here is 2 by 3. Okay, so let's cancel out 3, 3. So it comes out to be half. Now, what is going to be the answer here? Option number B. Okay. So this is how we have utilized this particular concept of rational numbers using to find the area of a rectangle. Let's continue to the next sum. Now, P and Q are two coprime numbers. Now, first, what are coprime numbers? Coprime numbers are any two numbers which do not have any factors in common except one. So one is a factor of everything, right? So we are not going to take one as an ideology to find our coprime numbers. Like for example, if I take 5 and 6, there are no numbers by which 5 and 6 are common. The factors of 5 and 6 are common. If I take 6 and 12, 12, 6 is a factor of 12. Okay. If I say 15 and 17, okay, see, 15 has, let me write it down and show it. For example, if I write 15 and 17, the factors of 17 are nothing but 1 and 17. The factors of 15 are going to be 1, 3, 5 and 15. There are no common factors except 1. So these two are coprime numbers. Okay? Okay. So P and Q are two coprime numbers, and then the number P by Q is a rational number if Q is not equal to 0. P and Q are coprime. P do not have any common factors other than 1. Okay. This is what we have done. So another thing before starting off, if I give you one example, for example, I give an example of 15 by 75. Okay. So these two numbers are not coprime. What? Why? Because we can divide 15 by 5 and we get 3. 75 by 5 we get 1. 25. Okay, now this 1 and 5 are coprime numbers, and thus we have to always write this down in the simplest format. This is what is given, two coprimes. Okay, we have to write that fraction in a simplest form such that we can not divide the numerator denominator again and again. Let's continue. Now it's a video. What is the standard form, simplest form of rational number? whatever I've told you, now you'll be getting to see that through a video. Let's see that. Second, standard form.
Look at the rational number 4 by 8. Is this the only way in which this rational number can be written? No, if we divide the numerator and the denominator by 2, it will be equal to 2 by 4. Remember, these two rational numbers are equivalent. If we again divide the numerator and the denominator by 2, we can write it as 1 by 2. So the original rational number was reduced to 1 by 2, which cannot be reduced further. This is called the standard form of a rational number. This 1 and 2 are the lowest possible integers for this fraction. The standard form of a rational number is defined as p by q, where p and q are the lowest possible integers, and q is always positive. The original fraction was 4 by 8. How do we reduce it to its standard form? We can divide the numerator and the denominator by 4 and get the answer as 1 by 2. But what is this 4? How do we find it? 4 is the highest common factor of 4 and 8. That is the HCF of the numerator and the denominator. So whenever you want to reduce a rational number to its standard form, all you need to do is divide its numerator and denominator by the HCF of the numerator and the denominator.
Okay, so we have now realized that what is the simplest form or the standard form of a rational number. So it's basically the same thing that we have done in fractions. The simplest term in fractions and standard form of rational numbers are more or less the same. Okay, let's continue. Now next, another video. What are positive and negative rational numbers? Okay, the name itself will give you away what are positive and negative rational numbers. This video will be shown by me after a while, but before that, let me just explain to you before watching the video. So if I say I have 0 here, plus 1 here, and minus 1 here, and I want to fill up the middle points with any random arbitrary numbers. So if I divide this part, it is going to be in minus. This all points are going to be in minus. Similarly, this all points are going to be on plus. Okay, so if I say this number is 0 0.1, 0 0.2, 0 0.3, these are decimals. So decimals conversion to fraction is going to be 1 by 10, 2 by 10, 3 by 10, 4 by 10, like that. So these are all positive. Similarly here, minus 1 by 10, minus 2 by 10, minus 3 by 10. These are all going to be negative rational numbers. Okay, this is what are positive and negative rational numbers. Now let's go on to watch the video so that our concept is more or less done.
How do we define a rational number? It is a number of the form p by q, where p and q are integers and q is not equal to 0. In this video, we will talk about the signs of the numerator and the denominator. Consider 2 by 7. This is a rational number. Let's make three columns of p, q, and the result. We will think of different combinations of the signs of the numerator and the denominator and then see the sign of the final result. In this case, the numerator as well as the denominator is positive. So we can say this rational number is positive. We say that 2 by 7 is a positive rational number. Let's think of another number. Say minus 2 by minus 7. Here, P as well as Q are negative. Does that mean this is negative? Let's write it down on a scratch paper. Minus 2 by minus 7. Let's multiply the numerator as well as the denominator by minus 1. This means that we are just multiplying it by 1. Minus 2 times minus 1 gives us 2, and minus 7 times minus 1 gives us 7. This means that this rational number is equivalent to this one, and it is positive. Here's your third rational number, minus 2 by 7. Here, the numerator is negative and the denominator is positive. So this negative sign will remain, which is why it is a negative rational number. Here, we got rid of the negative sign as both the numerator as well as the denominator had it. What if the rational number is like 2 by minus 7? P is positive and Q is negative. This rational number as well is negative as the minus sign remains. The fourth rational number is actually the same as this rational number. 2 by minus 7 is our rational number. Let's multiply the numerator and the denominator by minus 1. In the numerator, we get a minus 2, and in the denominator, a product of two negative numbers gives us a positive number. We get the third rational number, which is also negative. Remember, if any one of the numerator or the denominator is negative, the rational number is negative. If both are positive or both are negative, then the rational number is positive.
Okay, so we have learned about what are positive and negative rational numbers. Okay, it is very easy to understand. Probably I would realize that you people have got to understand what that is. So let's continue to the next portion. Now, rational number in standard form we have already done. Standard form and lowest term are the same. Okay, so a rational number m by n is in standard form is n is positive and m and m have only one as their common factor. Okay, so कुछ नहीं है, simplest fraction in case of a fraction is same as standard form in case of a rational number. Next, let's see. The rational number 3 by 4 is in standard form as 4 is positive and both 3 and 4 have only one of their factors in common. So here 3 and 4 are co-prime of each other. So that is it. The entire definition is nothing but that simple. Now, minus 5 by 7, 8 by 11, 15 by minus 13 is negative rational numbers. Okay, so we have till now cleared what is the basic of rational number, what is the standard form of rational numbers, what is positive rational number, what is negative rational numbers. Okay, let's now there are some sums. Write down rational numbers whose numerator is the largest number of 2 digits and denominator is the smallest number of 4 digits. Okay, so largest number of 2 digits. What is the largest number of 2 digits? Okay, it's 99. And denominator is the smallest number of 4 digits, so 1000. So this is our answer for the first one. Okay, as simple as that, just a step. Write the numerator of each of the following rational numbers. So we just have to write the numerator part. We all know this is numerator and this is denominator. So in the first one, numerator is minus 125. In the second one is positive 37. In the third one, it is negative 85. In the fourth one, see, when a number like this is given, a natural number like this is given, a whole number 0 is given. Now, every number has its denominator as 1. Even 0 has a denominator 1. Okay, so the numerator is going to be nothing but the top number. Okay, so here 2, the answer is going to be 2 here. Here 0, the answer is going to be 0 here. That's it. Now, write the denominator. We have already found out what to write the numerator now. Now it's time for denominators. Okay, denominator for the first one is minus 15. For the second one is 29. For the third one it's 4. For the fourth one it is going to be nothing but 1. This one is important. Okay, minus 7, if it's written over here, minus 7 divided by 1, that will be the answer. Minus 7 divided by 1. So numerator minus 7, denominator 1, denominator here will be 1. Similarly here 0 by 1 or 0, but 0 by 0 is undefined, so we have only one correct answer, that is 1. So in both of these cases denominator is going to be 1. Okay, Move on to the next portion. So these are all the solutions that we have done. Okay, now we have to first start off with the chapter by solution. Okay, before starting off with this, I would like to make sure that you understand some basic concept of an equation. So if there is an equation and I have positive sign over here, if it goes to the other side of the equal to sign, it will become negative. Similarly, a negative signs, if it goes to the other side of the equal to sign, it will become positive. A multiplication, if it goes to the opposite side of the equal to sign, it becomes division. And a division, if it goes into the opposite side of equal to, it becomes multiplication. Okay, so this and this are reversible, nothing like that. Okay, so I think this is very easy for you to understand, or you already covered this. Now let's go head straight into the sum. The first one, let's see the first one over here. Okay, so here we have to find the value of x. First one is minus 2 by 3 is equal to 6 by x. Let's make x as the subject. This is equal to minus 2x is equal to 18. So x is going to be equal to 18 divided by minus 2. It is going to be x ka value is going to be minus 9. Now from the second one, okay, I'll be doing it directly. How directly? Let me make that understandable to you guys. So here minus 4 and 8, we know both of them are in division. So this will go up here, this will go up here. Why are we spending time solving this, right? So you already know it's going to be deducted, or it is going to be like divided. So we are going to straight write 4 and this is going to be 2. Minus sign goes up and value of x is going to be minus 40. Okay. Similarly for the second one, this and this 5, value of x is going to be minus 15. For the fourth one, this and this, so 6 directly divides this and then how much? So even if you forgot anything, just try to do it with the basic like multiplication that you know. Like for example, who forgets 2? So 2, 3, this is going to be 24. Again 3, this is going to be 8. So value of x is going to be minus 8. Okay, and for the last one, this and this is 12. The value of this will be 1 remaining here. X value will be equal to 12. Similarly, for the last one, 9, this cancels also 3. X value comes around to minus 3. Okay. So first one I've shown you how to do it, and second from the second one to the last one, I like try to save your time. Okay. If you did not understand this, do watch the video, solve it in the first like type as well, so you'll get the same answer. Chalo. So this is the solutions for each and every one. Now now we come on to the properties of rational numbers. We have already done properties of like what is additive inverse, what is multiplicative, identity, everything we have done in the last session, last class, no, last like in class 7. So now we have to understand the properties of rational numbers. So firstly comes what is the closure property. Let's head on straight to the video of closure property. There are three properties, right? Closure, commutative, and associative. Let's start off with the most basic, that is the closure property.
We will be studying the properties of four operations on rational numbers. And those operations are addition, subtraction, multiplication, and division. There are quite a few properties we will look at, but let's analyze the closure property first. Closure property is very easy. It asks us, does an operation on any two rational number result in a rational number? If yes, then the closure property is satisfied for that operation. If no, then the closure property is not satisfied. Let's start with addition. To test if the closure property is satisfied for addition, we take two random rational numbers, add them, and see if we get a rational number. We can try adding 3 divided by 2 and 4 divided by 5. To add two rational numbers with different denominators, we have to make the denominators same. The least common multiple of 2 and 5 is 10. We can write 3 by 2 as 15 by 10. They are equivalent rational numbers. and 4 by 5 can be written as 8 by 10. Adding the numerators over the common denominator, we get 23 divided by 10. This is a rational number. The addition of two rational numbers will always result in a rational number. This tells us that the closure property is satisfied for addition. Is it satisfied for subtraction? We take two random numbers again and subtract them to see if we get a rational number. Let us try 11 by 6 minus 8 by 3. The LCM of 6 and 3 is 6. So we write it as 11 by 6 minus 16 by 6. This ratio was kept as is, and this ratio was written as 16 by 6. Subtracting the numerators over the denominator gives us minus 5 by 6 as the answer. This too is a rational number. No matter what numbers you take, subtraction of two rational numbers will always result in a rational number. The closure property is therefore satisfied for subtraction of rational numbers as well. Actually, the closure property is satisfied for multiplication as well as division. We have looked at only two examples in this video. I would suggest you to take random rational numbers and try out different operations to see if you get rational numbers as your result.
Okay, so this was what is necessary for understanding closure property. Now, as we have shown closure property, I think all the properties are there one after the other. Yeah. So now comes the portion for commutative property. Okay. So let's watch the all the videos of the properties first. After that, we'll continue. So as I can see, commutative property is there, then associative property is there, then zero properties is there. So let's finish all the properties one after the other. After that, we'll start off with the sums directly and make sure you understand everything. Okay. So now let's start off with commutative property.
In the previous video, we have seen that the closure property is satisfied for all the four operations on rational numbers. In this video, we will look at the commutative property. The commutative property is also very simple to understand. To know if it's satisfied for addition, we have to ask ourselves, does A plus B equal B plus A, where A and B are rational numbers? If yes, then the commutative property is satisfied for addition of rational numbers. Consider addition of two random rational numbers, 1 by 4 plus 1 by 3. The LCM of 4 and 3 is 12, so this can be written as 3 by 12 plus 4 by 12. This rational number is the equivalent of this one, and this rational number is the equivalent of this one. And adding both numbers, we get 7 by 12. This was A plus B. Now let's change the order. Now we write 1 by 3 plus 1 by 4. Again, the LCM of the denominators is 12. Using the concept of equivalent rational numbers, we can write this as 4 by 12 plus 3 by 12, which gives us 7 by 12. In both the cases, we get the same answer, 7 by 12. For this reason, we can say that 1 by 4 plus 1 by 3 equals 1 by 3 plus 1 by 4. And this will be the case for any two rational numbers. So we can say that the commutative property is satisfied for addition of rational numbers. Let's move on to the next operation now, subtraction. To know if it's valid for subtraction, we just check if A minus B equals B minus A. We consider two random rational numbers again. Let us try out 2 by 3 minus 1 by 5. This is of the form A minus B. First, we find this result and then see the result of this minus this. The two negative signs cancel out and it can be written as 2 by 3 plus 1 by 5. Making the denominator same, we can write this as 10 by 15 plus 3 by 15. This is 2 by 3 and this is 1 by 5. Adding the numerators over the denominator, we get 13 by 15 as our answer. Now let's try minus 1 by 5 minus 2 by 3. This can be written as minus 3 by 15 minus 10 by 15. Subtracting the numerators over the common denominator, we get minus 13 by 15. So we can see 2 by 3 minus 1 by 5 does not equal minus 1 by 5 minus 2 by 3. So this property is never satisfied for subtraction of two different rational numbers. For multiplication, we have to find out if a multiplied by b equals b multiplied by a. Yes, the commutative property is always satisfied for multiplication of rational numbers. And to test it for division, we need to check if a divided by b is equal to b divided by a. If you try this for two different rational numbers, you will notice that the commutative property is not satisfied for division. To find out if the commutative property is satisfied for an operation, all you need to do is find out if A operation B is equal to B operation A. If yes, then the property is satisfied.
Okay, this was about commutative property. Now let's head straight into what is associative property. Let me play the video a little bit fast.
What does the associative property actually mean? Let's start with the associative property for addition. To know if it's satisfied for addition, we just need to check if A plus B plus C equals A plus B plus C, where A, B, and C are rational numbers. Notice that on the left hand side, A plus B are in brackets, and on the right hand side, B plus C are in brackets. We take three random rational numbers now. Say 3 divided by 2, minus 4 divided by 5, and minus 4 divided by 3. Let us put the brackets around the first two numbers and keep the third one as is. In mathematics, based on the order of operations, brackets have to be solved first. This is how the calculations will look like. To solve the brackets, we make the denominators of these two rational numbers 10. We get this value as 7 by 10. Then we made the denominators of these two rational numbers equal to 30. And we finally got the answer as minus 19 by 30. Now we can put the brackets around the second and the third terms. The sum will look like this with brackets around these two terms. Again, we first solve the brackets and then come to this term. We made the denominators of these two terms equal to 15 and got the answer within the brackets as minus 32 by 15. Then we made the denominators of these two terms equal to 30 and got the answer as minus 19 by 30. Don't focus too hard on the calculations. The concept of associative property is important. So the answer in both the cases is the same. We can say that the associative property is satisfied for addition of rational numbers. I know one example is not enough to prove anything. So to be sure, please solve a few examples on your own by choosing three random rational numbers. Let's move on to the next operation. To see if the property is for subtraction, we need to check if a minus b minus c equals a minus b minus c. We choose three random numbers again. Say 3 by 5, 4 by 3, and 1 by 4. We put brackets around the first two terms here. This is a minus b minus c. This equals minus 59 by 60. We solve the brackets first to get minus 11 by 15 and then make the denominators equal to 60. Now let us group the second and the third terms. We will have to solve this part first. We get the final answer as 16 by 60. Solving the brackets, we get 4 by 12 and solving this, we get 16 by 60. Is that equal to minus 59 by 60? No, so we can say the associative property is not satisfied for subtraction of rational numbers. And if you experiment a bit more with rational numbers, you will know that the associative property is satisfied with multiplication and not satisfied with division.
This was all about the properties. Okay, now we'll shift on to understand what is the zero property. Okay, now this is a property that very few of us knows, but it's a very basic and easy property. Let's give it a try. After that, we have only sums. Let me speed up this video as well.
What exactly is the zero property for addition? Here, we just want to know what answer we get when we add a zero to a rational number. Say we add a zero to a rational number 11 by 5. If we add 0, we get 11 by 5, which is the same as the original number. Similarly, 0 plus 11 by 5 also gives us 11 by 5. As we studied earlier, 0 is called an additive identity. Whenever it is added to a rational number, the answer will also be a rational number. For subtraction, we want to know the result we get when we subtract a 0 from a rational number. We take an example of a random rational number again. Say 4 by 5. 4 by 5 minus 0 gives us the same number, which is 4 by 5. So can we call 0 the subtractive identity? No, we cannot. Why not? Let's try solving 0 minus 4 by 5. It gives us minus 4 by 5, which is not the same as the original number. And minus 4 by 5 is called the additive inverse of 4 by 5. We will understand additive inverse in another video. It is the number which is added to a number to get a 0. For multiplication, we know that any number multiplied by 0 gives us 0. 3 by 2 multiplied by 0 equals 0. And 0 multiplied by 3 by 2 also equals 0. And what about division? We know that any number divided by 0 is undefined. And 0 divided by any non-zero number is 0.
Okay, so this was all about the zero properties. Now let's head back straight to the class. We have understood till zero property, we have all watched the videos. Now, so these are all the properties that we have covered. So closure property have already done. What are closure property? Then how do we add to rational numbers? Okay, see more videos on rational number, how to add. Let's do some sums and then let's find out. Okay, see, if I take first, let me take an example and after that we'll move forward. Let's take a number with the same denominator so that we do not have to use the LCM wala concept. So first, let's take a number like 12 divided by 7 plus 13 divided by 7. Okay, so both of them are rational numbers. We're adding it same denominator, so LCM is going to be 7 only, right? So we're getting the answer as nothing but 7. 12 plus 13, that becomes nothing but 25. So 25 by 7. Okay, now let's take the denominator as different something. So 12 by 7, and in this place let me take 13 by 14. Okay, so 7 and 14, let me add one more number, 5 by 21. Let's make it more difficult. Okay, now LCM of 7, 14 and 21, let's find it out. So before finding out LCM, I would like to tell you that the usage of 7 here is not required because 7 is in both 14 and 21. So how did I get this? So 7 is nothing but 7 into 1, right? 14 is nothing but 7 into 2. And 21 is nothing but 7 into 3. So the LCM here is the largest common multiple. So 7 is present for each of them. So the extra numbers are nothing but 2 and 3. So the answer will be 7 into 6. This will be the answer. Now 7 6 are what? It's 42. So this is going to be the LCM. Okay. So let's write the answer down. As the LCM is going to be 42. Now 7 6 are 42. 12 6 are what? 72. Plus 14 3s are, now 13 into 3, 39. 12 twos are, so this is 10. Okay, so I'm writing it here. So 42 again in the denominator. So 39 plus 10, 49. 49 plus 72. Here, I'll show you one more method in order to solve the sum, 72 and 49. Okay, so why cannot we write it as 70 and 50 plus 2 minus 1? This is also the same, right? So this 72 can be written as 70 plus 2, 49, 50 minus 1. So 70 plus 50, 120, 120 to 121. So 121 by 42 is going to be the answer. Okay, this is how we're going to add all the rational numbers. Okay, now associative property we've already learned. This is the property. We know how to solve this one by one. We have already watched the video regarding this. Now, existence of additive identity. This is also we have covered in the zero property wala theorem. So 0 plus any number, any rational number will give us that number itself. Now, existence of additive inverse. Additive inverse is what? Any number that will give us, by adding to a number, will give us 0. For example, what did I say? If I get a number 2 by 7 and I need to add something in order to make it 0, it will always be the same number but with a negative sign. This will be 2 by 7. Okay. Now, how did we find that out? Simple. I am just rubbing this particular portion plus x. So x is equal to, this comes in opposite side of the, this will be minus 2 by 7. This is what is known as additive inverse. Why? Because we are adding. That is it. Multiplicative inverse, let me figure it out in one way only. So I have 2 by 7 into 1 is equal to 2 by 7. Now this is known as what? Multiplicative identity. The multiplicative inverse is what? 2 by 7 into what will give me 1. That's it. So this will nothing be the inverse or the reciprocal of that number. So 7 by 2. So we have done what is like additive inverse and multiplicative inverse, additive identity, multiplicative identity. Still, if you have any issues, we'll be doing sums as well. So let's evaluate this. First, let's evaluate the first one. After that, the second one. Okay. So you can pause the video and try to solve it from yourself. Okay. And after that, you can unpause and see my solution. So I will firstly, I will do what? I will take the ones with the denominator as same in a bracket. Okay. So 3 by 4, I will just write it like this: 3 by 4 plus minus 1 by 4 plus 5 by 6 minus 7 by 6. You can also write it like this. It's the same. Now denominators are the same, right? This will be 2, 3 minus 1, 2. Denominator again same, minus 2. Okay. Now what is the LCM of these two? It's 12. So 4 threes are, so 2 into 3 plus minus 2 into 2, 6 minus 4 by 12. So 2 by 12, and the answer comes out to be 1 by 6. Okay, this is the answer for the first one. Now let's take the LCM of all the numbers simultaneously. Okay, so whenever there is a negative sign in the denominator, that will be like, that won't be an issue, because this I'm writing it in the top word: minus 9 by 10 plus 4 by 15 minus 3 by 20 minus 3 by 10 plus 8 by 15 minus 9 by 20. So this can be written like this as well. So that is, there is no difference whatever written in the question and whatever written in the top part of the screen. So what are the numbers and denominators? Let me write it. So 10, 15, 20, again 10, so I'm not writing it down. 15 again, not writing it down. 20 again. So we have to find out for these three. Okay, so the answer is 60 here, but let me find it out. Okay, first 5, 2, 3, 4, again 2, 1, 3, 2. Okay, so 6 into 10, 5 into 2, 10. So the answer is going to be 60. Okay, so let's write it down. 60 here. 10 6 are 10 6 are, so minus 9 into 6 plus 15 4s are, so 16 minus 9 minus 18 plus 424 minus 27. Okay, so I'm writing this here: minus 54 minus 9 minus 18 minus 27. I've written down all the minus wala portions, then plus 16 and 24. That will give me nothing but 10 1 3 40 divided by 60. Okay, now see, everything are multiples of 9, right? So 54 is 9 6 are, let's add 1, 9 7s are, 9 sevens, 9 8, 9 9. So this is nothing but, let me explain it to you. Okay, this is 9 6 are, right? This is 9 1s are, 9 2s are, and 9 3s are, right? So if we take 9 common from the entire thing, we are getting 6 plus 1. So this is nothing but 9 into 6, 7, 8, 9, 10, 11, 12. Okay. So, and negative sign is there in front of it, plus 40 by 60. Okay. So 9 12 is 108. So minus 108 plus 40 divided by 60. Okay. So it is becoming a little bit clumsy. Let me clear the previous sum out so that I can write this properly. Okay. So let's calculate this. So 108 minus 40 minus 68 by 60. 2 ka table, so this is 24, sorry, 34, this is 30, again 15, 17. So answer comes out to be minus 17 by 50. Okay, so this is the solution for the second one. Let's continue. So this is the first one. Okay, second one we have already calculated. Now this is a sum for you. A basket contains 5 whole 1 by 2 kgs of apple and 3 whole 2 by kgs of oranges. Find the total weight of the fruit in the basket. Let me teach you a good method to solve this kind of sums. Okay, 5.5 plus 3 2 by 3. Okay, let's take the whole portion of this sum out. So 5 plus 3 plus half plus 2 by 3. We can write this as well, right? It is going to be 8 plus, let's take the LCM of these two. So 6, so 3 plus 4. Okay, so 8, 7 by 6. Now this converts nothing but, okay, there you go. We did not find the LCM of all those numbers, we calculated this directly. But if you want to solve it, you can. Okay, if you want to solve it in a normal way, we can. So 2, 10, 11 plus 3, 9, 10, 11. Similarly 6, 33 plus 22, 55 by 6, 9 and 1 by 6. The same answer. Okay. Now how do we subtract? No point watching the video again. Okay, we all know how to subtract using the LCM, and the same concept used for addition. Let's try to do some sum. So always remember, while subtracting, one thing is always important. If I say subtract x from y, okay, now after from what is given, that should be the first one. Subtract this is the second term. Okay, from the right hand side first term minus subtract this. Okay, so if I change this and I write subtract 10 from minus 20, we can see minus present here and 10 present here. Please don't say the answer as minus 10 or 10 plus 10, whatever. Okay, what is written on the right hand side of the right hand side of from, it's minus 20, so minus 20 minus 10, the answer is going to be minus 30, not minus 10. Okay, this has to be remembered for each and every subtraction sums. Okay, now let's solve for this sum that is given on the board. See, now subtraction of 3 by 4 from 5 by 6. Right hand side of from is what? 5 by 6. So 5 by 6 in front minus 3 by 4. Now after solving it, we are getting this. Let's continue to the next sum. Now utilizing the same thing, closure property. Now properties of subtraction, same thing we have already covered. We have already covered associative, since the identity. Multiplicative, we have covered everything. Yes. Now let's head straight to, this is multiplicative identity. I've already told you 1 into multiplication of any number will give that number only. Okay, multiplicative inverse, I've just told you it is nothing but reciprocal of that particular number. Nothing. Reciprocal is what? If I have fraction 2 by 3, I have any fraction, for example 997 by 1371. Now what is the multiplicative inverse of this? Is going to be reverse. So 1371 by 997. Okay, just remember this. With practice, this will also be very easy for you to understand. Now comes out to be the distributive property. What are distributive property? Let me give with an example. If I have, okay, let's take the most easiest one, but not even with rational numbers. Let's take it with natural numbers only first. Okay. If I say 2, 7 plus 3. Okay. We solve it how? We solve it like, we will first, you're gonna say, okay, we'll solve the bracket first. 7 plus 3 is 10. Answer is 20. If I say we have another thing to solve it, so first we multiply 2 into 7 plus 2 into 3. So we are distributing the value 2 inside the bracket equally on the two numbers. So we are getting 14 plus 6, that is also 20. The same thing is going to get utilized in rational numbers as well. So let us do with an example. 1 by 2 into 3 by 4 plus 2 by 6. Okay. So again 1 by 2 into 3 by 4 plus 1 by 2 into 2 by 6. Okay, so in the first one nothing is getting divided, right? So we're going to write 3 by 8, and in the second one we're going to write 2 and 2 is divided, the 1 by 6. 3 by 8 plus 1 by 6. Now let's add this up. So 8 and 6, 8 and 6, what is going to be the answer? 24. LCM here is 24. So 8 threes are, so 3 into 3, that is going to be 9, plus 6 fours are, so this is 4. So 9 plus 4 is 13. 13 by 24. That is the answer. So we have used nothing but the distributive property of multiplication. That is it. Let's continue. Okay. Now another sum here. If the length and breadth of a rectangular paper is 2 whole 2 by 7 and 1 whole 1 by 7 respectively, its area and perimeter. Okay. Let's solve it. First area is what? Length into breadth. Length we have known as 8, 16, 16, 17, 19, 21, 23 into 23 by 7. Good. So this comes the area, and now it's time for the perimeter. That is 2 length plus breadth, right? So 2L plus 2 breadth, we are using the distributive property again. So 2 into 23 by 8 plus 2 into 8 by 7. Okay, so this will give us 4. So we are remaining 23 by 4 plus, this is 8, right? Huh? 16 by 7. See, 4 and 7 no common factors, so these are co-prime. So in case of co-prime LCM, you just multiply both of the terms. The answer here is going to be 28. Okay, so 23 into 7 plus 16 into 4. Okay, after solving this, we are gonna get the answer. Let's solve it on 21, 14, 15, 16, 161 plus 16 4s are 24, 4, 5, 6, 64 divided by 28. We get 5, 12, 1, 2, 2, 5 by 28. Okay, And this is going to be the answer for this area and perimeter. Okay, so 2 to 5 by 28 and 23 by 7. I've not converted into the mixed fraction. You can do it. So now comes the last thing, that is division. Let's head straight to the sums. Okay, but before this, division to region number is not communicative. Oh, we have already done this. So the videos of those properties. Now, last portion of the chapter, rational numbers on a number line. There is a video. I think that video will help you to understand how to draw the number line and how to make sure all the numbers are separated from a number line. What are the negative, what are the positive numbers, and how to divide that particular number line into parts so that we can calculate it on rational number scale. Okay, let's watch the video first. See, first it's about plotting 3 by 4, how to plot 3 by 4. There are many videos, one after the other like this, but we'll try my best to make sure you understand everything. Okay, let's begin.
How do we represent rational numbers on a number line? A number line looks something like this. The positive integers are represented towards the right of 0, and the negative integers are represented to the left of 0. The numbers increase when we move towards the right and decrease when we move towards the left. It's easy to plot integers, but how do we plot numbers like 3 by 4? Before we understand how to plot this, we need to understand a very crucial point. Every integer except 0 has a corresponding integer. The integer 1 has minus 1 as its corresponding integer. The integer 2 has minus 2 as its corresponding integer. Similarly, every negative integer will have a corresponding positive integer. This tells us that if we somehow manage to plot 3 by 4, we can mark a point at the same distance on the left-hand side of 0, which is minus 3 by 4. Now we can move on to the representation of rational numbers on a number line. To simplify things, we can classify the examples into two types. One in which the numerator is less than the denominator, and the other in which the numerator is greater than the denominator. Note that we see only the numerical value to compare the numerator and the denominator. For example, if we are plotting minus 9 by 5, we compare 9 and 5 and not minus 9 and 5. So minus 9 by 5 will come in the numerator greater than denominator category. We will look at two examples of the first category in the next video. One of the categories of plotting the rational numbers on the number line is when the numerators are less than the denominators. Let's try to plot 1 by 2 and minus 1 by 2 on the number line. First, we see how we can plot 1 by 2. The numerator 1 is less than the denominator 2. When the numerator is less than the denominator, the positive rational number will be between 0 and 1. So we draw the number line like this. The number 1 by 2 has to lie somewhere between 0 and 1. Now we divide the length between 0 and 1 into equal parts. How many equal parts is the question? The denominator tells us the number of equal parts. The denominator is 2, so we divide it into 2 equal parts. This line divides this region into 2 equal parts. But what does the numerator tell us? It tells us the number of parts starting from 0. The numerator is 1, and therefore we take 1 part from 0 and mark 1 by 2 here. We can use the same procedure to mark minus 1 by 2 on the left side of 0. Divide it into 2 parts and mark minus 1 by 2, 1 part away from 0. Just as integers have corresponding values, rational numbers too have corresponding values. In our example, minus 1 by 2 corresponds to 1 by 2. Let us us look at another example where the numerator is less than the denominator. We have to plot 3 by 4 and minus 3 by 4. Let us plot 3 by 4 first. Since the numerator is less than the denominator, we know that the number will be between 0 and 1. So we draw the number line like this, with just 0 and 1 plotted. Remember, the denominator tells us the number of equal parts. Since the denominator is 4, we divide the length between 0 and 1 into 4 equal parts. Drawing these three lines gives us 4 equal parts. Now we move to the numerator. The numerator tells us the number of parts from the number 0. Since the numerator is 3, we move 3 equal parts from 0. 1, 2, and 3. So we mark 3 by 4 here. Now let us plot minus 3 by 4. Since 3 is less than 4 and the rational number is negative, we know that it will come between 0 and minus 1. We divide this length into 4 equal parts as the denominator is 4. And we mark minus 3 by 4, 3 parts away from 0. That's it. We have plotted the points. But let me ask you a question. You have plotted the numbers 3 by 4 and minus 3 by 4. But do you know which numbers are plotted on these points? Here's your answer. Since this is one part, we mark 1 by 4 here. Since these are two parts, we mark 2 by 4 here. Similarly, we can plot minus 1 by 4 and minus 2 by 4 here. This was just for your understanding, and you don't need to mark all the points if you're asked to mark just 3 by 4 and minus 3 by 4. In the next video, we will look at an example in which the numerator is greater than the denominator. In this video, we will try to plot rational numbers whose numerators are greater than their denominators. Let us plot 7 by 4 and minus 7 by 4. We try to plot 7 by 4 first. The first step in such kind of problems, where the numerator is greater than the denominator, is to convert it into a mixed fraction form. You would have learned this in your earlier classes, but let me quickly show you how. We only have to divide 7 by 4. We get the quotient as 1 and the remainder as 3. So we write the mixed fraction as quotient, remainder by divisor. This is the whole part and this is the fractional part. So we can write 7 by 4 as 1, 3 by 4. 1 is called the whole number part and 3 by 4 is called the proper fraction part. Each of the three numbers, 1, 3 and 4, tell us something about where 7 by 4 is plotted on the number line. The whole number part tells us the position of 7 by 4. So 1 tells us that the rational number 7 by 4 is between itself and the next whole number. The next whole number is 2. So we know that 7 by 4 is between 1 and 2. So we draw the number line accordingly with just 0, 1 and 2 marked. The denominator of the proper fraction part tells us the number of equal parts this segment is divided into. Since it is 4, we divide this segment into 4 parts. This segment between 1 and 2 is divided into 4 equal parts. The numerator of the proper fraction tells us the number of parts from the first whole number. So it is 3 parts away from 1. So we mark 7 by 4 here. What about minus 7 by 4? We can write minus 7 by 4 as minus 1, 3 by 4. Now the number minus 1 tells us that minus 7 by 4 is between itself and the next number. Make note of the fact that the next number will be on the left hand side since minus 7 by 4 is a negative rational number. So the next number is minus 2. Now we can say that minus 7 by 4 is between minus 1 and minus 2. The denominator tells us the number of equal parts this length is divided into. So we divide it into 4 equal parts by marking 3 lines. The number 3 tells us the number of parts from the number minus 1. So leaving 3 parts from minus 1, we mark minus 7 by 4 here. With that, we are done with the topic of plotting positive and negative rational numbers. Please practice this concept thoroughly and make note of the summary which appears at the end of this video.
Okay, guys. So now we have understood how to rationalize number on a number line. Okay. So first thing, is it mixed fraction? Is the numerator greater or denominator greater? Denominator signifies the number of parts the line is going to be, like two numbers are going to be divided from. Okay. Then let's do some sums and after this we'll realize. Okay. Then what is this? Now these two parts but something that is very easy to understand and very difficult if you don't understand. That is the reason why videos are brought here. Let me first try to explain these sums to you. After that, we'll come back to the video if you are having any problem with it. Okay. So inserting rational numbers between two given rational numbers. Okay. Okay. So inserting rational numbers between two given rational numbers. Okay. Let's begin. So I have 2 by 5 and 2 by 7. Okay, two rational numbers, 2 by 5 and 2 by 7. Now I will insert some rational numbers in between them. First thing what I will do is I will make sure both of the denominators are the same. Okay, so denominator is same, matlab LCM, nothing else. So 2 into 7 divided by 5 into 7 for this, and for the second one 2 into 5 into 7 into 5. This comes out to be nothing but 14 by 35 and 10 by 35. Okay. Now, by utilizing this concept, we already understood which is greater and which is smaller. Okay. So 10 is smaller, right, than 14. So similarly, we can say that 2 by 7 is smaller than 2 by 5. That's it. But now let's insert some more numbers. So we can easily see just by the naked eye that we have 11 by 35, 12 by 35, 13 by 35 here. Now if we need even more, okay, if we need even more, multiply these two numbers by 2, by 3, by 4, whatever, just multiply it. So if you multiply, we are getting 28 by 70, and here I'll just multiply it by 2. 20 by 70. Now we get even more numbers in between them. We get 21 by 70, 22 by 70, like that till 27 by 70. Okay. If we need even more, multiplied by 3, 4, we keep on getting numbers after numbers between any two particular rational numbers. Okay. I'll play the video as well, guys. Okay. After completion of this. So let's insert two rational numbers between 7 and 8. Okay, now here I have the best. I have the option to do anything I want to. Now, firstly, you would realize, okay, there is nothing between 7 and 8. There is. In decimals, between 7 and 8, there are 7.1, 7.2, 7.3. Even between 7 and 7.1, there is 7.01, 7.02. Even between the 7.01 and 7.02, there are 7.001, 7.002. It goes on and on and on. Okay. So now most easiest way to find between two consecutive numbers is just find the average. That is what they have done here. Just finding the average. Average 17.7.5. Now again, the average of these two, 7 plus 7.5 by 2. An average of the other two, 7.5 plus 8 by 2. We're getting more numbers. We keep on finding the average. We keep on finding numbers in between. Okay. This is also a method, but this method is mainly utilized for numbers that are natural number or whole numbers. Okay. Integers as well, but we'll prefer to do like rational numbers in the format that I have shown you in the last example. Okay, now last sum probably I think, but still find three rational numbers between 3 by 5 and 4 by 7. Let's solve it step by step. So I have a number 3 by 5 and 4 by 7. First step, LCM same. Okay, so I have 35, 321, and here I have again 35, 4, 20. Okay, I have this. So let me check if I did it correctly or not. 5 7 35, 7 into 3 21, 7 5s are 35, 4 5s are 20. Okay. So now there are C. That is exactly the next number, right? So we need to find at least three rational numbers between them, right? So multiply both of them by 2. So this numbers converts into what? 42 by 70 and 40 by 70. We are getting one rational number here, 41 by 70. Okay, so multiply this and this again by 2. We are getting 84 by 140, and we are getting 80 by 140. Okay, so here we have found out what? We have found out 81 by 140, 82 by 140, and 83 by 140. Thus, finding three rational numbers between these two. So, from the number 3 by 5 to 4 by 7, we found out rational numbers between them. There is another method to solve this, but that won't require rational number, that required use to convert this into decimals. So, if we convert this into decimals, both of them, if I convert 3 by 5 in decimal, I am getting 0.6. Okay, 4 by 7 into decimal, I am getting 0.5, then 50, 0.57. Okay, so if it's in decimals, we can easily say that 0.58, 0.59. So these two numbers are already found out. Okay, but still in this particular method, as even converting to decimals, we are finding out only two. Okay, so this method is the one that should be utilized by you. Whatever method you find to be much more easier to solve, you can utilize that particular thing. Okay, let's find out how they have given the solution for this. Okay, they have utilized the average method. Okay, there are many particular methods that you can find out. So they have just found out the average. Here the average is not like what you think. There is no LCM over here. They just added both of the numerators, both of the denominator, numerator, denominator. Like that, they have found out numbers. This is very easy, but I would want you to understand the previous concepts as well, so that even going forward, even if you forget to find out which number is bigger, which rational number is greater or lesser, you can find the LCM method or rule in order to understand what this is. Okay. Now, how do you find rational numbers? We have already done this with examples. Now last, insert 5 rational numbers between 3 by 4 and 7 by 8. Okay, let's solve it. So 3 by 4, now utilize that average method, what we have found out. Okay, so first let's add these two. So 10 by 12, so 3 by 4, 10 by 12, 7 by 8. Finally, again these two adding to 16, 13, 16 by 13, 10 by 12, 20, 17, 7 by 8. Okay, so now let me add these two. So 16 by 20, comma 28 by 23. One second, guys. After this, after 3 by 4, after 3 by 4, there will be this. Then after this, there will be this. Then after this, there will be this. Now we have covered this, we have covered this. We have found the average here, now 10 by 12. Okay. So similarly, we have already found out 5. We have found more than 5 just by using the average method. Okay. So you can utilize the average method, or you can utilize this as well. Okay. This is the average method where we find the average of both of the two just by adding the numerator and denominator separately. So 3 by 4, 7 by 8, okay, into 2, into 2. So this becomes 6 by 8, 7 by 8. Okay. So LCM is same for both of them. Now just multiply this by 3, by 3, into 3, into 3. Okay. I'm getting here 18 by 24 and 21 by 24. Okay, so I got how many numbers in between? 19, 20, 19 by 24 and 20 by 24. Now see, there is one more method to find out. I here need 5 rational numbers. So if I multiply it by 3, I got 2. So if I multiply it by 6, I should get 5. Let's follow that intuition. So 6 into 6 by 8 into 6. 7 into 6 by 8 into 6. 6 6 are 36. This is 48, 42 by 48. So number of like in between 37 by 48, 38 by 48, 39 by 48, 40 by 48, 41 by 48. By this method also we can find out five rational numbers. Okay. So whatever method you are comfortable in doing, you can find that and solve the sums. Okay. Here they have made use of the LCM method. Okay. So there you go. They have like we have solved till here, right? So they have utilized this and made it into a simplest format, nothing else. Okay. 38 and 48 are both divisible by 2. They have written 9 by 24 here. 40 by 48 are both divisible by 2. Oh, this is divisible by 4 as well. So 10 by 5 by 6 is also because this is divisible by 8 as well. So 5 by 6. That is it. So this are the entire thing that we have done regarding rational numbers. If you have any problem or any issues regarding any particular sum, please write us in the comment section. I'll make sure to publish another video regarding this. Okay. Thank you.